Hi everyone, in this video I will talk about the concept of binomial random variable. Binomial random variable. In our previous video we talked about Bernoulli random variable. What's special about Bernoulli is that for Bernoulli we only have one try, so we'll only do it once. So Bernoulli it's only one trial, and if we have more than one trial, or if we're interested in doing more trials, then we'll use the concept of binomial. Binomial, in this case, it's or let me just say this one n goes to 1, and for binomials n greater than 1. So we have multiple trials for binomial. So binomial is just many repeats of Bernoulli random variable, right? So for Bernoulli we do one trial, and then for binomial we're going to do multiple trials. Let me go ahead and do an example in this case. So example, you're going to toss your coin 9 times, right? You're going to toss your coin 9 times. Remember in the example in our previous video, we talked about you're going to toss your coin once, right? Once is Bernoulli. 9 times is binomial. And then we're going to ask the question, what is the probability of getting 7 heads, right? So if we define heads to be success, what the question is asking is, if you toss your coin 9 times or you do 9 trials, what's the probability that you get 7 success? In this question, we're still assuming the probability of getting success is 1/2, right? We're still assuming that the coin is a fair coin. Okay, let me rewrite this information in terms of notations. So n represents how many trials we do. So in this question, n equals to 9, and then k represents how many success we want. In this case, is 7. And the probability of getting success in this case it's 1/2, right? So n, number of trials, k, number of success, and then p is the probability of getting success. Okay, to answer this question or solve this question, we are gonna use the following formula. So we need to learn the binomial formula. Okay, the binomial formula is n factorial over k factorial n minus k factorial. Okay, multiplied by the probability of success raised to k, number of success, and then multiply 1 minus p raised to n minus k. So number of trials factorial, number of success factorial, number of trial minus number of success factorial multiplied by the probability of success raised to number of success, and this is the probability of failure raised to n minus k, which is the number of failure. Okay, cool. And yeah, n factorial, what does this factorial symbol mean? So n factorial means n multiplied by n minus 1 multiplied by n minus 2 and keep multiplying until 1. Okay, just keep multiplying until 1. Okay, so now let's plug in these numbers into this formula and see how we can solve this question here. Okay. Okay, so in our case, or in our question, the question is the probability that we're doing 9 trials and getting 7 success. Okay, and this equals to n, which is 9 factorial, 7 success factorial. 9 minus 7 equals to 2 factorial. Okay, and then the probability of getting success raised to 7, and then 1 minus 1/2 is 1/2, and 2 failures, which is n minus k. And let's solve this. 9 factorial equals to 9 times 8 times 7 all the way times 1. And 7 factorial, 7 times 6 times 5 all the way to 1. And 2 factorial, just 2 multiplied by 1. Okay. And then here, we can simplify this into 1/2, 9. One thing I want to mention here is what you can see is this. So what are the common factors that this part and this part have, right? The common factor is 7 multiplied by 6 all the way to 1. So these two can be cancelled, right? 7 times 6 times 5 all the way times 1. You know, it's exactly the same as in this part. So this part can be simplified to 9 times 8. And then 2 times 1, 2 times 1. And this equals to 1. And multiply by 1/2 to the 9th power. And let me continue from this side. And this equals to 9 times 4, right? So 8 and the 2 cancelled. Multiply by 1/2 to the 9th power. And this equals to 36 times 1/2 to the 9. Okay. So this is the probability that you are doing n trials and you have 7 success, with the probability being 1/2 means that the coin is a fair coin. Okay, I got the answer here. Now let's do this question, but assuming that the coin is not a fair coin. So let's assume that. So now assume the probability of getting success instead of 1/2 is 1/4. And then the probability of getting a failure or getting a tail is 3/4. Okay? So let's do this question again. So the probability of n trials and getting 7 success is equals to 9 factorial, 7 factorial, 2 factorial. This part stays the same, but in the probability part, we have 1/4 raised to 7 and 3/4 raised to 2. Okay, so since we changed the probability, and let's just keep solving it. So this equals to, again, 9 times 8 divided by 2 times 1, because it will be the same as this part. And then here, we have, if you do the calculation, this part equals to 1/16,384, and then times 9/16. Okay, and then if you solve this, these fractions out, you get 648 divided by 524,288, and that's approximately equals to 0.00124. And this is the probability that you get 7 success from 9 trials, with the probability of getting success equals to 1/4. Okay? Sounds good. Now I'm gonna introduce you to the related parameters. Okay. So now we're going to talk about parameters of binomial random variables. Okay. So the first one is again expected value. which means that of the n trials, what is the expected success that you'll get, right? So expected of binomial equals to n trials times the probability of getting a success. Next is the variance of a binomial. So variance of binomial equals to n times p times 1 minus p, which is number of trials times probability of success times the probability of failure. And finally, the standard deviation. The deviation is just standard deviation of binomial equals to the square root of n times p times 1 minus p, which is the square root of the variance. Okay, this video talks about the concept of binomial random variables. Thank you for watching. I'll see you in the next video.